So in this video, we're just going to cover what we did in class, and that was talking about simplifying fractions. So when we're dealing with rectangular hyperbola, we prefer our rules to look like this. And the reason why is because it's immediately evident what my vertical asymptote will be. In this case, it will be x equals negative c. And my horizontal asymptote will be y equals plus d. So these c and d make it very easy to identify what my asymptotes will be. But let's say you were given this. Well, it's far less obvious to tell what my asymptotes are. It's actually quite easy to tell what my vertical asymptote will be. So in other words, what can't x equal for this to be true? Well, x can't equal negative 2 because negative 2 plus 2 will be 0. So it's actually just as easy to find my x asymptote, but it's harder to find my y because I don't have this plus d on the end as I do up here. So what we're going to be doing in this video, just recapping what we did in class, is find out how to get this into this form. So let me rub out and let's start exploring together. Let me zoom in. Okay. So as I said before, we actually like what our denominator is. So we keep it the same. And I'm actually going to put my denominator up the top as well. So at the moment I have 1. X plus 2 divided by x plus 2 is 1. But we want these to be the same. I have an x in my numerator, and I have an x in my numerator. I have a minus 5 here, but a plus 2 here. So I want to make this plus 2 into a minus 5. How would I do that? I would do that by minusing 7, because 2 minus 7 is minus 5. So now my numerators are the same. It's almost as if I broke this negative 5 into plus 2 and negative 7. I then can go to my next step, which is breaking this up. So I'm going to get x plus 2 over x plus 2 and negative 7 over x plus 2. So all I've done from this step to this step is break up my fraction. I then realize that x plus 2 divided by x plus 2 will be 1. Let me do it in green. 1. And I'm going to leave this the same. Negative 7 over x plus 2. So this here will be my answer. Now, it's far easier to identify what my asymptotes will be. So my y asymptote will be 1, and my x asymptote will be negative 2. So as you can see, by doing this simplifying fractions method, it is easier for me to identify what my asymptotes are, and that's why we're doing this. Let's now move on to my next example, which is up here. Again, you should probably pause the video and see if you can do this yourself, following the steps I showed. So the first things first is I write down my denominator. I then put that in my numerator. I have minus 4 here. Whoops. I have minus 4, but I want plus 3. So in order to make this plus 3, I'm going to have to plus 7. I then rewrite out my equation, so I'm going to get x minus 4 divided by x minus 4 plus 7 x minus 4. These will cancel out and give me 1, and this will stay the same. I then can identify what my asymptotes will be. This will be my y asymptote, and this will be my x asymptote. So I'm going to get y equals negative 1 and x equals 4. Let's now move on to our next example. This one is a little different. I now have a coefficient in front of my x in the numerator. Don't freak out. All we do is follow our protocol. we keep x plus 1 the same. I then put x plus 1 up here. I now need these numerators to be the same. If this has a coefficient of 2, then this needs to have a coefficient of 2. So I'm going to put a 2 here. Now I have 2x, and this 2 is also going to times this 1. I'm going to get 2x plus 2. So let me write this out really clearly. So in my numerator, on the left-hand side, I have 2x minus 3. And on my left-hand side, I'm going to have 2x plus 2. So all I've done is expand out this bracket to get 2x plus 2. But I don't want 2 here. I want negative 3. So what am I going to have to do to this side to make it negative 3? I'm going to have to minus 5. So I'm going to have to minus 5 here. So this was just a working outline to show you my logic for getting minus 5. I then continue with my standard protocol. I come here, I go 2, whoopsie daisy, let's keep the colors the same because I think that helps with our understanding. X plus 1 over x plus 1 minus 5 x plus 1. These cancel out. I am therefore left with 2 minus 5 over x plus 1. I then am able to identify my asymptotes. It will be 2, and x will equal negative 1. So my asymptotes will be x equals negative 1 and y equals 2. Let's now move on to my next example, which is 3x minus 5 over x minus 2. Again, we follow our protocol. I would put my denominator here. They're the same. I then put this here. This time, I have 3 as my coefficient, so I'm going to have to put a 3 here. Therefore, I'm going to get 3x, and then 3 times 2 is going to be 6, so it's going to be 3x minus 6. Let me just do a line of working to show you my logic here. So this 3x minus 5 is this, and on this side, once I expand out this 3, it's going to get me 3x minus 6. Now I have a minus 6 here, I have a minus 5 here. How am I going to make this minus 6 into a minus 5? Well, I'm going to have to plus 1. By plussing 1, I'm going to make it into a negative 5. So again, this was just working out to show you how I was making my numerators the same. Let me rub this out. My next step is breaking things up, and let's also remember this is all underneath that. So I'm going to get 3 x minus 2 x minus 2 plus 1 x minus 2. I cancel. I'm going to get 3 plus 1 over x minus 2. So that tells me that my y asymptote will be 3 and my x asymptote will be 2. So my y asymptote will be 3 and my x asymptote will be 2. Let's now move on to our next one. So in this one, we actually have to graph it as well. But before we worry about graphing, let's just make sure that we can draw it correctly. All right, so the first thing that we do is we put 2x plus 1 on the bottom, the same denominators. I then put this denominator up the top. Okay, this is where some of us might get tricked. Remember, I want my numerators to be the same. So if this has 1 as a coefficient. So if I want a 1 in front of this, how am I going to get rid of this 2? If I times it by a half, 1/2 times 2 will be 1. So I'm going to get rid of the coefficient, so it's going to look like this. Therefore, if I was to do a line representing me equating my two numerators, I would get x minus 4 for my left-hand side equals, after I expand out with this 1/2, I'm going to get an x here because 2 times 1/2 is x, and then I'm going to get a half times 1 is plus a half. So now I'm in the situation where I have negative 4 and plus 1/2. I want this 1/2 to become this negative 4. How am I going to do that? So let me write out in maths what I want. I have negative 4. Actually, let me do it this way. I have 1/2, and I'm going to have to plus something to it in order to get to negative 4. What am I going to have to plus or minus to my 1/2 to get negative 4? Well, I do some rearranging. I'm going to minus 1/2 from that side, 1/2 from here. Then we do x. This shows you the importance of making sure you are really rock solid with your ability to add and subtract fractions. Because if I was to really spell this out, I have negative 4 minus 1/2, which is the same as saying I need my same denominators. So I'm going to get negative 8 over 2 minus 1/2, which is going to be x equals negative 8 minus 1 is negative 9. So this, I really shouldn't have used x as my example because we already had x there. So that was actually my bad. Let me use something else. Let me say w. W, w, w. So this w is going to equal negative 9 over 2. And this is what I'm going to have to minus to my 1/2 in order for it to become negative 4. So I'm going to come up here and I'm going to say in order for this 1 over 2 to become negative 4, I'm going to have to minus 9 over 2, which tells me that up here it's going to have to be 9 over 2. So now I rub all this out because all of this was just working to get that 9 over 2. I rub all this out. Let me zoom out. It's just me cleaning up. Okay, now I'm here. So again, just like before, I'm going to break this up. I'm going to have 1/2 here, 2x plus 1, close the bracket, 2x plus 1, and then going to go minus 9 over 2 over 2x plus 1. This cancels out. So therefore, on this side, I'm left with 1/2. Now, people in the class today got a bit puzzled when they saw this, and rightly so. This is a bit strange. I have a fraction over 9 over 2. I have 9 over 2 over 2x plus 1. Obviously, you wouldn't want to write it that way. The way that you do write it is go minus 9 over 2, 2x plus 1. So as you can see, my numerator stayed on top, and then this 2 came on the bottom. If you wanted some explanation as to how I went from this to this, let me just do it slightly. These videos are good because they kind of just give me the freedom and time to discuss these issues. So what this is telling me, if I was to write this in really plain English, is 9 over 2 divided by 2x plus 1, 2x plus 1. Now hopefully I could do this and no one would get confused because any number divided by 1 is just itself. So this is just itself. 2x plus 1 is the same as 2x plus 1 over 1. The reason why I've done that is because what's the rule of dividing fractions? Hopefully you remember your, when did you learn this? You would have learned this quite a little while ago. Stay, change, flip. Keep this the same, change this division into a times, and then flip this over. So I'm going to get 1, 2x plus 1. So I'm going to get 9 on the top because 9 times 1 is 9, and then I'm going to get 2 on the bottom. So that's why I was able to write it like this. Hopefully this makes sense. If not, you might just need to brush up a little on your fractions. Come talk to me. I'd be happy to talk about it with you. Let me now get rid of that. Delete. Doesn't want to delete. Oh, delete. Alright. So now I have this. And I would go, okay, I need to write down my asymptotes. So my y asymptote is going to be a half from here. And my x asymptote will be negative a half. How did I know that my x asymptote would be negative a half? Well, this is my denominator. It's 2x plus 1. And I know that I can't let whatever is within this bracket become 0. Because if whatever was in this bracket became 0, I would get 0 times 2 is 0, which is 0, and I can't divide by 0. So what I would have to do is get this and go 2x plus 1 cannot equal 0. I would then rearrange, bring this negative 1 onto the other side. I've run out of room. I'm just going to have to do this. Then I'm going to get x equals negative 1 over 2. So that's how I got my x asymptote. So my x is negative a half and my y equals 1 over 2. I then need to graph this. So y is going to be here. Y equals 1 over 2. And x is going to be negative 1/2. So it's going to be here. X equals negative a half. Oops. This is a very long question. I now need to zoom out. Before I draw it, so let me just highlight this. This is my final nice equation. I need to find what my x and y intercepts are before I start sketching, just to make sure I do it correctly. So to find my x-intercept, I'm going to let y equal 0. But let's notice I have two options here. I could use my newly modified one, or I could use the original one. And it's actually going to be easier to use the original, and it's going to become very obvious why once I start doing it. So let me get a new color. Let me get green. Let me get orange. So I need to find my x-intercept, and I'm going to do that by letting y equal 0. So I'm going to get 0 equals x minus 4 over 2x plus 1. I then am going to times both sides by 2x plus 1. I'm going to times both sides by 2x plus 1. 2x plus 1. And that's to get rid of my denominator. So that's going to go away. And 0 times anything is just 0. So I'm left with 0 on this side. And then I'm going to get x minus 4. I then am going to plus 4 to both sides. And I'm going to get 4 equals x. So that will be my x-intercept right here. 4, 0. To find my y-intercept, I'm going to let x. To find my y-intercept, I'm going to let x equal 0. 0 minus 4. 2, 0 plus 1. So that is going to equal negative 4 in my numerator. 2 times 0 is 0 plus 1 is 1. Negative 4 over 1 is negative 4. That will be my y-intercept. So right here, it will be 0, negative 4. I can then graph this. Let me graph it in blue so I know where, whoops, sorry, this is very hard to graph on this tablet. So that's going down. It's going like that. Sorry about that. And then this is going to be doing this. Perfect. So again, my asymptotes are x equals negative a half and y equals a half. And my final equation is 1 over 2 minus 9 over 2x plus 1. Now we come to the lucky last. Oopsie daisy. So again, we do the same thing. Let me zoom right in. The first thing I'm going to do is make my denominator the same, 3x minus 2. I'm going to bring this up the top. I realize that here I don't have any coefficient, so I'm going to have to get rid of this 3, and I'm going to do that by timesing it by 1/3. And now I'm going to get 1/3 times 3 is x, minus 2 times 1/3, 2 times 1 over 3 is 2/3. So let me write this out because I want my numerators to be the same. So I'm going to get x minus 6 on this side. And then once I expand out with this 1/3, I'm going to get x minus 1/3 times -2 is 2/3. So as you can see, my x's are now the same, but what I want is -6 to be this. I want -2/3 to be -6. So I could write this out. I could say I have -2/3, but I want it to become -6. So I'm going to have to plus or minus it to something. What is this w going to equal? So I'm going to plus 2/3 to both sides, plus 2/3 to both sides. That will go away. I'll have w on this side. And now I have -6 plus 2/3. In order to plus those, I'm going to have to make my denominators the same. So I'm going to have to times this by 3 and this by 3 and then get 2/3. Come down. What is -18 plus 2? It's going to be 16 on 3. So this 16 on 3 is what I'm going to have to plus on this side in order to make -2/3 into -6. Oopsie daisy. Sorry guys, I made a mistake. -18 plus 2 is -16. -16. Which means this will be negative. I saw that -6, I'm like, what happened there? So it's going to be -16 over 3. -16 over 3. That's what I'm going to have to minus. So I'm going to have to go minus 2/3 minus 16 over 3 in order to get this -6 there. Perfect. So now I come over here and, sorry, before I do that, this was all just working out. Sometimes you kind of get wrapped up in this and think that that's what you're doing. That's going to be here. Then I'm going to rub all this out. Whoops. So I'm going to get 3x minus 2 there. I'm going to get 1/3. 3x minus 2 minus 16 on 3 over 3x minus 2. That will go away with that. I'll be left with 1/3 on this side. And then here I'll have 16 on the top, then 3, then 3x minus 2. So now when I come to do my asymptotes, my y asymptote will be 1/3, and my x asymptote will be 2/3. Then I would come over here and I would graph it. So I'm going to get x equals 2/3 and y equals 1/3. I then need to find what my x and y intercepts are. Oops. So to find my x-intercept, let y equal 0. Again, using the same logic, I'm going to use this one up here. So it's going to be 0 equals x minus 6 over 3x minus 2. I'm going to times both sides by 3x minus 2. I'm going to be left with 0 equals minus 6. And therefore, I'm going to be left with 6 equals x. That right there will be my x-intercept. So I'm going to come over here now and say I'm going to hit this at 6, 0. I then come down here and I need to now find my y-intercept. To do that, I'm going to let x equal 0. So I'm going to get y equals 0 minus 6. 3, 0 minus 2, minus 6 here, minus 2 there. My negatives goes away. I'm left with 3. So that works perfectly. So right there, oops, let's try to make this a bit to scale. So it's going to be like there. And let me do this. Actually, probably best to do it here. 0, 3. So 0, 3, 6, 0. Sorry about the bad sketching there. These should be nice, curved, smooth lines. But there you go. There's everything we needed to go over. So for the last one, my asymptotes was y equals 1/3 and x equals 2/3. Hopefully this little video was helpful to those of you who are stuck on this problem. And again, these videos are purely supplementary. You don't need to watch them, but if you just needed a recap of the lesson, it's here for your help. Thank you very much.